Hello, welcome to today's maths tutorial video. We're going to be looking at the discriminant today, which is something that's linked to the wider quadratics chapter. It's possible some of you might have already come across the term the discriminant before and might know vaguely what it is. So for those of you to which that applies to, I'm going to include a timestamp in the video's description which will allow you to skip ahead to the part of the video where we look at specifically how the discriminant can be used in A-level questions. But for those of you who are wondering what the discriminant actually is, let's start off by answering that, which is to point out it's just a formula. It's just the formula b squared minus 4ac, where the a, b, and c are the coefficients of a quadratic equation. The a being the coefficient of x squared, b being the coefficient of x, and the c being the constant term on the end. The b squared minus 4ac is technically just a part of the wider quadratic formula, specifically the part that's usually under the square root, but therefore it is worth pointing out that the discriminant, when we refer to that term, we're talking about the part not including the square root itself. So it's just the b squared minus 4ac part, not the square root on top of it as well. And the discriminant is useful because it helps us find out how many roots a quadratic equation has. How does that work though? Well, let's take a look at some brief examples. If, for instance, you have this quadratic equation, calculating the discriminant means we're going to be doing minus 7 all squared, minus 4 times 1 times 6, because our b is minus 7, that's the number in front of the x. Our a is 1 because we've got one lot of x squared, and then the c is equal to 6 because of the constant term on the end. If you do some number crunching, that will end up being 25, although I would like to draw your attention once again to remind you, if you're squaring a negative number, do make sure you put brackets around it, because even if you're typing this stuff into a calculator, the calculator follows the laws of BIDMAS, so in order to make sure the minus is happening before the squared, you need those brackets there. Anyway, because our discriminant is a positive number, that tells us our quadratic in this case has two real roots. Even without actually having to bother finding what those roots are, the discriminant alone is enough to tell us that. But the reason it tells us that is because it's, as I said, a positive number, and that has an impact when we're coming to use the quadratic formula. Because, of course, the quadratic formula is minus b, so in this case that would be minus 7, so positive 7, plus or minus usually the square root of the discriminant, the b squared minus 4ac part, all divided by two lots of the value of a. That's important because if the discriminant is a positive number, that means we can square root it to get a real number, and then that means we're going to end up with two roots because one of the roots is going to be formed by taking the plus part of the plus minus symbol and adding on our square root of our discriminant, so square root of 25 is 5, divided by 2, and that would get us one of the roots, and then the second root would then be obtained by doing the same process, but instead of choosing the plus part of the plus minus, you choose the minus part instead. Again, recalculate it, and that's what gets you the second root when you finish the number crunching. Cool, so that's one case that can happen. A second quadratic here though, because if we look at this quadratic and calculate the discriminant for it, we end up with the discriminant being 0. That's important because the discriminant's equal to 0. It tells us that our quadratic equation only had one real root, one distinct real root I should say, and that's because if we again proceed on to using the quadratic formula, we're going to end up with minus b plus or minus the square root of our discriminant all over two lots of a, and that's important because this time it means we're adding 0 or taking away 0 when looking at our two different options for our roots. But the problem is, if you add 0 onto something or take away 0 onto something, it has the same result, which is to do nothing to that number. So therefore, either way, you're still only going to end up with one root, which only is going to come from the minus b part at the beginning and then the over 2a part. So therefore, if your discriminant is equal to 0, you know you're only going to have one distinct real root just because of the structure of how the discriminant affects the quadratic formula. And then the third situation you can get is when you have quadratics that are of this style, because if you calculate the discriminant for this quadratic, you'll get minus 16. I've skipped the number crunching there, but b squared minus 4ac, same as usual. In this case, you get minus 16, and that tells you you've got no real roots. I should emphasize that I'm being really careful with my wording there by saying there's no real roots, because those of you who study maths further, then what you study in Maths A-level will look at this scenario in more detail, but therefore for the moment I'll say there's no real roots, because in Maths A-level we only deal with real numbers. Anyway, the reason that causes us to have no real roots is, again, if you look at the quadratic formula and start trying to use the quadratic formula, you'd have minus b plus or minus the square root of the discriminant all over 2a, and then you're left with a bit of a problem, because immediately we're having to, as part of that formula, square root a negative number, which we know is not possible to do if we're trying to get real numbers, so therefore we can't proceed any further, and that's why there's no real roots. There's no real roots that we can calculate based on what the formula is telling us. So that's what the discriminant is, and also how it can be used to tell how many roots a quadratic equation has. However, I should point out it's very unlikely that you'll ever be asked at A-level to just determine the number of roots a quadratic has. And the reason for that is, ultimately, although the discriminant is the quickest way of telling how many roots an equation has, it's possible that you would be able to find how many roots an equation has without knowing what the discriminant is and how it works, because you could just try to brute force it by manually trying to find the numbers of roots by trying to find the roots themselves, because that doesn't take that much more effort if you've got a calculator and you're just doing the number crunching. So instead, at Maths A-level, what you're more likely to be asked is you're more likely to be given information about how many roots the equation has before you start, but then you're meant to be able to use that information to work backwards to have information about what the original quadratic must have been. So, with that said, here's what you need to know for A-level. For a start, you need to be aware there's certain clues you can watch out for to know that it's going to be a discriminant question. Namely, the moment a question mentions the number of roots or solutions that an equation has before you've actually even done anything with it. That's suspicious because normally, as I said, you'd be just trying to find the solutions, so the fact they're already telling you how many there are rather than just asking you to find them is instantly means we're linked to the discriminant, because the discriminant is interested in the number of roots or solutions an equation has. And therefore also the second thing is, just as I already mentioned, they're not asking you to actually find what the roots are, they're just telling you how many roots there are and then expecting you to use that to work backwards to find information about the original quadratic. And so once you've realised it's a discriminant question, the next thing you need to be doing is looking at what specific wording they have used to describe your given equation. If they've said that your quadratic is a quadratic that has two distinct real roots or two real solutions, then instantly you know that's the scenario where the discriminant was a positive number, so therefore you can set up the inequality b squared minus 4ac must be greater than 0. However, if instead you're told the quadratic has one distinct real root or one solution, or alternatively the phrases such as repeated roots or equal roots, then you know that's that middle scenario of b squared minus 4ac equals 0. Some students get a little thrown off when they see the fact that the wording one distinct real root is somehow the same as repeated roots, plural, because that seems weird. One minute we're saying there's one, and the next minute it sounds like we're saying there's several. Well, it's all just down to what happens if you actually try and solve a quadratic that's in this sort of scenario. If you have x squared minus 6x plus 9, for instance, if you use either the quadratic formula or factorizing, either way those methods try and work on the basis that there are two roots and they try to find them both. But in these cases, for those methods, either way, you'll end up with those methods finding the same root twice as part of doing them. So that's the whole idea of there being repeated roots, because the method still tries to find two roots, it's just they both happen to be the same one. And then the third and final scenario is the situation where there's no real roots, because that tells us that b squared minus 4ac must be less than 0, because you can't square root a negative number and get a real result from it. Cool. So that's what you need to be on the lookout for. However, actually, there are more things you need to be watching out for, but because this video is already going to be long enough as it is, we'll save that stuff for a second video on the discriminant, so do stay tuned for that. So let's take a look at some examples. This first example, we're trying to find the values of p for which this equation has no real roots. Straight away we can tell it's a discriminant question because they're telling us there's no real roots, either telling us how many solutions there are, and they don't actually ask us to find the solutions. In other words, they're not asking us to find the values of x. That's interesting because although there is a second algebra letter p's holding the role of almost being part of the coefficient of the x's, because a quadratic normally has an x squared, an x, and just a constant term, and then anything else is just part of the numbers that's in front of those things that help you then solve the quadratic. So putting that all into play, because it says no real roots, we know b squared minus 4ac is less than 0. Good idea to write down which scenario for the discriminant it is that you're dealing with for the method, or for the sake of method marks I should say, because it's showing that you can interpret the wording correctly before you even begin with actually doing the solving itself. And then you also got to identify your value of a, b, and c. And this is where it gets interesting because, as I said, the p is actually holding part of the role of the coefficient of x squared, so therefore actually our a is 5p, it's everything that's in front of the x squared. Our b, though, is more normal, just being a minus 3, and our c is also fairly normal, being just a 2. But yes, we can now start to have algebra as long as it's not the normal x involved in the actual values or expressions, I should say, for a, b, and c. So with that said, we can now plug those things in, so therefore we're going to end up with minus 3 all squared minus 4 times by our a times by our c, and that's got to be less than 0. And actually the rest of this question is then just trying to solve the inequality we've just set up. Minus 3 all squared is positive 9, minus 4 times by 2 times by 5p is 40p. And then solving that inequality, well, ultimately we're just going to then end up being able to add 40p onto both sides, because a reminder with inequalities, you're allowed to add or take away anything you like onto both sides of the inequality. Doesn't really affect things that much. And then we are allowed to divide both sides by 40 to realize the left hand side become 9 over 40. And then because we divide both sides by a positive number, the inequality sign doesn't change. So the final solution is p is any value greater than 9 over 40. That would result in our equation being an equation that's got no real roots. On to a second example, and in this case we've been given that the equation has repeated roots, and again therefore instantly realizing it's a discriminant question because they're mentioning how many roots there are and not asking us to actually find the roots themselves. But interestingly, you'll notice this time this equation looks more complicated. And that's noteworthy because a reminder, because the discriminant's part of the quadratic formula, therefore it'll only work when the equation's been rearranged, so it's the format of a quadratic set equal to 0, because that's the only scenario when the quadratic formula works. Therefore, the discriminant being a part of the quadratic formula, it's also true for that as well. So therefore, we're going to start by taking away 6x and 7k from both sides. So doing that, I get that. And we are also aware that our particular scenario, our particular question, is mentioning the fact there's repeated roots. So we know it's going to be b squared minus 4ac equals 0. But then we are left with a bit of a dilemma because we've got to decide what the value of a, b, and c are going to be. A is going to be very easy to find. It's just what's in front of the x squared, and there's an x squared there at the front with effectively no number in front, but therefore that tells us a is equal to 1. But you might start having a bit of a problem or a bit of a dilemma when you get to decide what the value of or expression for b is going to be. Because we know b is the expression for what's in front of x. But the problem is there's an x in more than one place. We've got the kx and we've got the minus 6x. And the b's got to take account of everything that's in front of the x, so the fact there's an x in more than one place makes it a little more scary. So what you might find beneficial to do is to factorize the x out of all the terms that involve just x to the power of 1. Because then it makes it clear the coefficient of the x, in terms of algebra in this case, is k minus 6. And then on the end, well, we had the 2 minus 7k still left to deal with. And some people, again, might be tempted to go, oh, our c is just going to be 2, but it isn't. The c is everything that's not part of the x squared or not part of the x. So all of that stuff on the end is our c. So that's another area where students get caught out. All we've got to do now is whack those things, or more technically, substitute them, I should say, into that discriminant equation we've set up. So therefore, we have k minus 6 all squared, minus 4 lots of 1, lots of 2 minus 7k, equals 0, because the discriminant equation we set up was equal to 0. Because of the wording that said repeated roots, I should point out, not because of the equals 0 we saw earlier. Anyway, so therefore, multiply out the brackets. First of all, make sure you multiply them out properly and fully. I've just jumped straight to that. If you need to do a grid method or whatever, make sure whatever you do, you don't drop silly marks by not multiplying out brackets properly. Then we've got to do the minus 4 times by 1, so that's just minus 4. Something that some people like to do if you're multiplying these sort of two pairs of brackets here is do in stages. So do minus 4 times by the 1, then multiply it by the third bracket, or second bracket, I should say. Well, it is third bracket overall, because then you're limiting how much you're doing in one step, which helps you avoid silly mistakes as well. So minus 4 times by 2 is minus 8. And minus 4 times by minus 7k is positive 28k. Obviously, some of you might have looked at that and thought it was a bit silly, because of course 4 times 1 then multiplied by the other bracket wouldn't have been too hard to do, but when the bracket that had the 1 in was more tricky, for those scenarios you might find it beneficial to break it down more like I have done here. Simplifying it, we've got k squared plus 28k minus 12k comes to 16k, and 36 take away 8 is positive 28. Then got to solve that quadratic. Luckily, that's a really nice quadratic. It's going to factorize. That is going to factorize to plus 14 plus 2, but that's just what it factorizes to. That doesn't tell us what k is instantly. We've got to then effectively solve the mini equations. You probably might not bother writing this stage because you might just jump to realizing k equals minus 14. Alternatively, k is equal to minus 2. So those are the possible values of k that cause our equation to have repeated roots. There you go. On to one more example for this video, and it looks more scary still. We've got to find the range of possible values for w if it's got two distinct solutions. So again, because of the wording, we know it's a discriminant question. We also know it's specifically the discriminant situation. That's b squared minus 4ac is greater than 0, because the discriminant's got to be a positive number if you're going to have two distinct roots or solutions. Our a is, of course, just the w, our b is the 3w minus 4, and our c is 2w. And we can plug those things in, so we're going to end up with 3w minus 4 all squared, minus 4 lots of w, lots of our c, which would be 2w. That's greater than 0. Again, just a bit of algebra rewriting, multiplying out the brackets, do it properly and fully. I'm going to be a good role model and show myself actually doing that. So if necessary, as I said, old school grid method. Obviously, as you get more confident with this, then you might not feel the need to do this, but the point is, I don't care what you do to get the question right, just get the question right. Make sure you do enough working that means you avoid silly mistakes. So therefore we've got that, so therefore we've got 9w squared, take away 24w, and then plus 16, and then we're taking away 8w squared. Cool, so we get w squared minus 24w plus 16 is greater than 0. Now, this is a quadratic inequality. If you haven't come across how to solve a quadratic inequality yet, then do watch my video on how to do that, and then come back to this example after that. But ultimately, at this stage, you're almost ignoring everything that's gone before. It's now just its own mini question of, well, here's a quadratic inequality, just solve this using the usual method for solving a quadratic inequality. So that's a thing to help with harder questions in Maths A-level, almost compartmentalizing the various stages of it and going, okay, I know what to do for this thing to solve this particular issue, and let's just get on with it, sort of thing. So you might remember, if you have watched or seen how to solve a quadratic inequality before, you first find critical values, which can be found by treating the equation, treating the inequality like an equation. Solving it, I'm going to use the quadratic formula because that looks nasty to solve otherwise. And then we've got two lots of 1 on the bottom. And then we're going to type that into the calculator to get w equals 12 plus or minus 8 root 2. Nice, so next you can draw a graph to help you decide what happens with the inequality sign. This is a positive quadratic. by the way, 12 plus 8 root 2 is positive, 12 minus 8 root 2 is positive, so it's going to look something like this. You'd work out them using decimals to know that roughly. But therefore I know that's where 12 minus 8 root 2 exists. That's where 12 plus 8 root 2 exists. And we want to find out where is the quadratic graph greater than y equals 0. In other words, where is the quadratic graph above the x-axis? That's that bit there. That's that bit there. So we use the y values to decide which part of the graph to shade, and then we use the x values to decide what happens to the inequality signs, even though confusingly we're talking about w. So that's something worth pointing out. It's a bit strange because we're talking about w here, so that's a bit different to what we're normally used to plotting on the graph. Anyway, we want to the left of 12 minus 8 root 2, so that means w is less than 12 minus 8 root 2. And we want to the right of 12 plus 8 root 2, so that's when w is greater than 12 plus 8 root 2. So therefore, that's the quadratic inequality solved. Therefore, those are the possible values for the discriminant solved as well. One little extra note though, something a bit weird to watch out for. In this particular question, it's always important to check your answers, check they make sense as well. And what you might notice is when you realize that this 12 minus 8 root 2 is a positive number, that means we're saying w is less than some positive number, whatever it is. But that means that 0 is included in that inequality. W equals 0 in theory satisfies that inequality. But the problem is, if you look at the original question and you try and plug w equals 0 in there, that wouldn't make sense. And the reason it wouldn't make sense is because if you plug w equals 0 in, that means we're going to have 0 lots of x squared. So instantly, it's not going to be possible to have two solutions because it won't be a quadratic anymore. It'll just be a normal x to the power of 1 graph. So therefore, actually you do have to watch out sometimes. There are sometimes in these questions some dodgy values that you've got to kind of make clear or reject because they just don't make sense in the context of the question. A rare situation, but I thought I'd point it out. Okay, hopefully you found today's video useful. If you didn't, I'm surprised that you're still watching, but thankful anyway. But we're also going to have a second video looking at some harder and more specific examples for when the discriminant can crop up as part of an exam question. So do stay tuned for that video. See you. Goodbye.